Right, so good evening, everybody. I want to believe that you can hear me loud and clear. Good evening, everybody. Can you hear me loud and clear?
Good evening,
Yes,
Prof.
please.
You can
Good evening. Ian.
Okay, that's right. Um, okay. The other day when we met, we discussed, in fact, that was our second lecture, and we look at the architecture of a relational database. We then look at the functions that a relational database should have. Then we look at the various architectures. Particularly, we look at the tiered architectures, 2-tier, then 3-tier, and so forth. Today, we will continue from there to our next chapter. Again, all the discussions we are having so far are fundamental, because I told you the first 3 classes will be introducing you to the basics. And after today, we'll begin to delve into a far more advanced but interesting topics. I did stress the fact that if you understand the fundamentals, it becomes easier to understand the advanced topics. These three topics or 3 lectures that I'm having with you are basically undergraduate content. But because some of you are reading this course, though you do not have the necessary, so to speak, computer science background, it becomes very important that I introduce you to the basics before we move on to the advanced topics. Otherwise, this course probably may not be useful to you. For those who have done these things before, I still believe that you will be learning some few new things, or at least refreshing your mind of what you have learned some time back. So today we will take the third chapter, and hopefully we will be done with it. I'll be giving you, I told you we'll be doing a project. I'll be giving you the first leg of the project, and the first leg will basically depend on all these fundamental things that we are learning. So at the tail end of the class, I would introduce you to the project, as I would later give you the full, the complete project to work on. It is going to be a group work, and everybody is expected to take part in the project. It will seriously help you, seriously. I've been receiving messages from some of my students I taught this course some in the previous years, and they were saying that it is helping them. And then some are even teaching, and they say he has even made their teaching better. A number of them are teaching in secondary schools, and then what do we call it? Training colleges, secondary schools, and then so forth. And they said they better understand the concepts and they can relate them well to their students. So since we are beginning from the fundamentals, I believe surely It will help any of you that take this course seriously. So I will again, as I usually do, open the floor for a while for questions. Perhaps you went home and you were glancing through what we did, and certain things came to mind. You told yourself that when you come to class today, you will find out from the lecturer. If there is anything like that, feel free. After all, that's why we are here. You can ask few questions and clarifications before we start today's class. Today's class is supposed to be a joint class. The weekend class, I told them the other day that this coming Saturday, one of our colleagues lost the mother, our staff member, colleague in our department, and therefore I would be part of the funeral, and therefore you should join today, and next week, Saturday, we will not meet. So if they are not here, they will need to be here. Otherwise, Saturday we are not going to meet. Okay, anybody with question, comments, some clarification before we move ahead? All right. Okay, so this is what we saw last week. Data models, conceptual model, functions of a database. We listed about 10 functions of the database of a relational database management systems. So anybody who would want to delve into developing that compiler should consider these 10 functions or integrate these 10 functions into it. The components are also here that we explained to some extent. We finalized everything by the tiered architectures, and we were able to explain what each tier represents. And we ended the class somewhere there. And today we will continue with very basic relational model. Despite all the advancement in various technologies, relational databases still relational databases still run number one when it comes to all types of databases. Having known that fact that relational databases are still the commonest, it's a good idea for us to know how we can model and design, implement relational databases. So the very fundamental that is needed to understand and work with relational databases is what we are coming to look at today. So the chapter would talk about some terminologies relating to relational model and how it is represented in the form of tables. The mathematical side will be left for another day. Then we'll see the properties of relations. We would identify keys, including super key, candidate key, primary key, uh, composite key, and several keys, even foreign keys. Then we will look at the integrity constraints and referential integrity. Then some advantages of using views. After that, I will introduce you to the project that we are coming to do. With the project, if you are able to do the project, then it convinces me that you've understood all that we are talking about. Okay. Now, just after the use, so to speak, or the implementation of flat file systems with all its related challenges, the I mentioned Dr. John Cott worked on a mathematical representation of how data should be represented. So he worked on that, and then he used mathematical operations with some variables that turn out to be attributes, and then see how they can be combined with mathematical operations in retrieval of data. So then that led to the development of relational databases. So now the relational databases are built on what we refer to as relation. And this relation can be understood physically as a table which is made up of rows and columns. In fact, on the user's view, when the user views the contents of the database, he sees it to be in the form of rows and columns that we refer to as a table. But as we saw the other day, when we look at the internal view, it's not rows and columns. So from the user's view, are made up of rows and columns. So this concept led us to the conceptual level where database designers like you will have to do a lot of work, because at that level we answer questions regarding which data are we coming to gather and store? How are we coming to store them? So these questions begin to come to mind, assuming that you, let's say, go to an office and they have shown you their business process, things that they do, and they bring some raw data, raw forms, and things that they do to carry out their business. How do you sit down to gather and then assemble, pull together related data that they will need and store them efficiently in a database? So everything starts from there. Everything starts from there. So we will also start from there as we define these things. I'll give you some, I'll be giving you some procedures that you will need to be following. So the first definition, there are a number of terms that we will define. The first term is relation. The relation normally is the same as saying a table, which is made up of rows and columns. It's sometimes look like, or most often looks like, how we see Excel sheets in rows and columns with cells representing the data values. Okay. Now, when we identify a row and a column, we would need to find a way to name the rows and then even the columns. So there is another term we call attributes. Attribute is a named column of a relation. So the columns, various columns that are presented in a relation are referred to as attributes. Now the attributes hold values. Attributes hold values. For instance, if we have a table which is made up of two attributes. One of them is, let's say, student ID, which is an attribute. And then let's say the second column is student gender. Student gender. This ID, student ID as a, so to speak, the column heading, which is an attribute, will hold values of student IDs. Students' gender will. Now, student gender will also hold some values. So that leads us to define this term, domain. So a domain is a set of allowable values for one or more attributes. So now, with this definition, if I mention, say, gender, what would be the allowable values for gender? Anybody? If I say gender, what will be allowable? Male,
yeah,
or
male
male or female. Yeah, that's allowable values for gender. It is probably recently when people are
there are other genders too.
People are making an attempt.
they add.
People are making an attempt to add some more, which is not really working for them. But so far as we know, it's male and gender. But despite that, when we are developing databases, we develop databases for business entities. So if those groups of people who believe that there are more than two, when we are developing a database for them, then you will need to provide for other options. Otherwise, their system cannot be used effectively. So it depends on where the business domain where you are developing the system. So if they contract you to develop a database for them, and they believe that there are many others, and the allowable values will be what and what now? What will it be now?
Male, female, other.
Male, female, other. Okay, that's right. Okay. Maybe you say other, then you can say specified if there are specific names for other. So it depends on where you are developing the system. But I believe in many institutions in Ghana, I think male and female could do. Okay, so that is domain. All these simple things will play into things that we will be seeing later on. So let's try to understand what a domain is. When we come to mathematical representation, we'll be mentioning this domain. A word domain again, at that time, the definition will not be there. But you will know that they are allowable values that represent an attribute or the attribute holds. Okay, so we just represent these things here. Let's see some other definition. Since we talked about the attribute being the attributes being the columns, then we also have tuples represent the rows in the relation. Okay. It is also, the tuples is also referred to as record. So you can see a record. Okay. Now, the other term of interest is degree. So the degree of a relation is the number of attributes it contains. So let's look at this one. What is the degree of this table? Figure 3.2, what is the degree? Anybody?
4.
It's 4, the number of attributes. 1, 2, 3, 4. So you are right. 4.
Prof,
Now,
but is the degree the same as the dimensionality?
maybe you can find out on your own. Okay. Now let's move to cardinality. So the degree is of a relation, a number of attributes it contains. So let's come to cardinality. The cardinality of a relation is the number of tuples it contains. So this one now comes to the number of records it contains. That is cardinality. For instance, when we take this one, we can count the number of records that it contains. How many records are in this table?
Which one? The top one or the down one?
Okay. Top one.
Six.
So that's the cardinality of that thing. That's the cardinality of that relation. Now let's come to relational database. Now, you see the way we identify these tables. For instance, these tables that we are seeing here, there are a number of, we have figure 3.1. Then we say branch. We have staff table, and it can be many others. Why is it that we do not put all these things into one table or one relation, but we have to be breaking them down into various relations? These are questions that relational database attempts to solve through what we call normalization. Because we can continue from here: branch number, street, city, postcode, staff number, that, and then we can continue. But why do we need to break it down into two? These are questions we need to be answering along the line. So now, since the relations or tables can be split, there is relational database is talking about the fact that there are collection of tables with distinct names. So we can have branch table, staff table, they all have distinct names. But then this collection of, here you see it's not collection of relations, normalized relations. This normalized carries a lot of, will be of interest to us in the next few classes. It's one of the things that number of students have not been able to do well when it comes to database design. I think that's the only challenge when it comes to database design for many people. Okay, so relational database is now about collection of several normalized relations or tables that each of them with its own name. We'll be dealing with normalization in the next few classes. So this summarizes the definitions that we are talking about in table 3.1. The relation is the same as table or even file. Tuple is the same as row or record. Attribute is the same as column or field. So you can use these terms interchangeably. Okay. Then before we move out from here to attempt to also look at these mathematical fundamentals, I'm not going to worry myself with it now. It's going to be part of our next class. Okay. Now let's move to look at I still want to get away from this mathematical representation. Okay. Now, as we want to look at some few things, I just want to bring to your attention anytime you want to collect some collect and store some data in a database, and then we provide some processing mechanisms with business rules. How do we start from the scratch? The first thing we will do is to, in most cases, what we do is, okay, can you see a new slide I'm sharing with you, some population sensors?
Yes, please.
Yes, Prof.
Yes,
Yes,
Prof.
please.
So you will see, let's say you want to design a database. Normally, you start from the scratch. If
Yes.
you now
Yes.
assuming that you are given, let's say statistical department has given you, and this is the way we do it to our officers go on the field, and then maybe they distribute or take these kind of forms, they will fill them, then we capture them into our system. So you are asked to develop a simple system, database system for them to be able to capture the raw data they collect from this form. In reality, all that we are learning, you need to start doing it from a point like this, because anytime you are coming to develop databases for businesses, they'll be giving you some forms, they will give you their business rule, they will give you how they do computations, and then so forth. Some of them are not well ordered, the documents, raw data. So you, as a database designer, has been given this from our statistical service wants you to develop a database for them. Now, you can't just go ahead and then develop buttons and then test boxes to be like the way it is over here. This is a report, which is, so to speak, will be pulled from your database. How do you go about things of this nature? And this is where you will need to know how to identify the entities. We define entity shortly. That entity, and I don't know whether we defined entity already. We haven't.
No, Prof.
Okay, an entity. You will need to identify that thing on which you want to collect the data. That thing or that place or that person or that form. So things of this nature are presented to you as something that you need to collect data on. Here you need to collect data on the population and housing. So when I look on this, how do I come out with my entities, attributes, their relationships, primary key, foreign keys, normalized tables? You see, at this point, what we are seeing on this screen can be the external view that we discussed the other time when we were looking at the various views. Yes, external view for viewer, the users to view the maybe contents, which could be a report. But when you come to your conceptual level, there is not what you will be seeing at the conceptual level. You are coming to break these things down into various tables, link them, normalize them, present them in such a manner that there will not be duplications, and so forth before you put interfaces on them for maybe records that are captured here to be inputted into your system for the database to store and for efficient retrieval. So that is an example of raw forms for you to do that. Sometimes you give this thing to students and they just look at this and then they create a table, region name, create something, district name, so something, something, something. Then they will go up to the point they create some screen for that one. Maybe they create another screen from here to somewhere. They create And then when they are creating the tables, so they just consider these names and then they just gather the names like that and then they create a table and they go. Then later on, because maybe they don't follow principles of data modeling, then the system begins to give clients problems and so forth. So as we discuss the lecture, I'll be referring you to this form, and then we'll go ahead. And then eventually, I'll be asking groups. I ask you to form groups. If I haven't asked you, you will need to form groups because most of our technology work is group work. I'll be giving you this form. Each group would model, look on this, and in your own understanding of how to model database, you come out with a model from this entity relationship model from this raw form, where you have several tables, and then the tables will be linked, properly normalized, and so forth, using concepts that we are coming to learn. Okay, so having said so, we can go ahead and look at the properties of a relation. The properties of a relation are listed over here. They are not difficult to understand. Okay, the relation must have a distinct name, which is important. A cell in the relation must, maybe some of these I should explain, or I shouldn't take it for granted. Okay, let me just explain. Each table or a relation must have a distinct name from all other names. Now, each cell, because now it's a row and column, they are made up of rows and columns. There are several cells. Each cell must contain exactly one value. Please bear that one in mind. Only atomic value, one value, should be placed into a cell. So if you made a mistake and you don't put atomic value into a cell, you are in for trouble later on. Okay, I'll give you an example. Let's say you are defining an attribute, and one of the attribute name is student name. Student name. When you say student name, the student name, when you want to enter the value, that means you are going to enter maybe first name, middle name, and surname into one cell. So once you do something like that, already it is wrong, because you are putting multi-value, more than one value into one cell. That's why most often, don't you see, we will say first name, middle name, last name. We will split the attribute into three or a number of them, so that we will not have to put we will not have to put multi-value into a cell. So take note of this. If you design a database and it's going to contain multi-value, then you are not following multi-values, then you are not following the proper relational modeling techniques. If you have a question on this, you can ask me. If you don't bear this one in mind, and we come to normalization, you'll be in trouble. These are the things that have been causing tables not to be properly normalized. One of them is this. Okay. Okay, there is a hand of Sadiq.
Good evening, Prof.
Yeah, good evening.
Please, I would like to find out these days some databases can store JSON values. So do they fall in the normalization range?
They can store what?
JSON values.
Okay.
JSON values.
Okay. Yeah, I understand what you are talking about. But at the background, we will need to normalize the tables properly. Okay. Each attribute must have a distinct name. The attributes must have distinct names. Then the values of an attribute are all from the same domain. So the values that fall under the attributes they must come from the same domain. For instance, if we say gender, the domain could be the domain male and female. You can't put another value there that may be age. They must come from the same domain. Each tuple should be distinct. So each record should be distinct. So you could not have two records of the same, or the same record repeat two times. No. Then the order of the attributes has no significance. It doesn't matter whether one attribute comes first before the other or vice versa. It doesn't really matter. But most of the time we try to put the primary key first. But it doesn't really matter. It's just a best practice that the first column is a primary key or a key of a type. Now the order of the records too is it's not significant. So if a certain record comes first or comes last or come in the middle, it doesn't got any significant theoretically, but in practice it can affect the efficiency of the system, particularly things about retrievals. Okay, so these are few properties of a relation. Now we want to also define certain relational keys for each of the records. Since each record should be unique, there must be a particular attribute that we will use to form a key. But there can be several keys in a table. And the terminologies that are used. So we will start from super key, an attribute or a set of attributes that uniquely identifies a tuple within a relation. Then we have candidate key, which may be a super key such that no proper subset of a subkey is found. Then we have a primary key, a candidate key. There can be several keys that can be used to identify a record, but the one that we have selected to be our main key, so to speak, or primary key, referred to as primary key. So it's a candidate key that is selected to identify records uniquely within the relation. Then we have foreign key, an attribute or a set of attributes within one relation that matches the candidate key, possibly in another relation. That's foreign key. This primary and foreign key concepts is what we call referential integrity. Referential integrity. And it's extremely useful when it comes to relational databases. Extremely useful when it comes to relational database. It is through this sort of primary and foreign keys that relational databases are based on, that we've been asking what kind of relationship exists among the tables, and we'll be talking about that very soon. Okay, we also have certain keys we call composite key. Sometimes you want to use not only one attribute to represent the key, but two or more attributes will combine to form a key. In that case, it's a composite key. Understanding composite key is also very important to the understanding of some aspects of normalization. Okay. So here, I'm sure you can see some tables in front of us here. Some samples of tables in front of us here. We have branch. This is a branch, an organization with branches. A branch and then staff table. Branch and staff table. Now, this branch entity, staff entity, property for rent, client entity, they are all various relations. Okay. These things are formulated from a business process or things we should gather some data on. And as I was trying to say earlier, that when we are working with databases or you want to start a database from the scratch, these days, most of the things we don't start from the scratch because maybe there is some system similar or some table similar and so forth. But sometimes the kind of information that you are presented with, you will need to start with all the tables, normalize them properly. And so if you are using relational databases. Okay. So for instance, this data I showed you over here, this raw data that I show you over here. Okay, when we are presented with things like this, where do you start from? Maybe I can make it open for anybody to suggest. You want to develop a database for statistical service. You are contracted to do so for them. And at least you'll get some money. And they give you this form that, okay, you do this simple one for us first. There is a bigger project coming. They get this one for us in a few weeks. Where do you start from? At least you will need to design the database. Anybody's idea? I know some of you have been doing things of this nature. At least your idea can help the class. Yes. Okay. Abdul Razak.
Sir, good evening.
Good evening.
Please with this, for me, like I will do it from the software side. That's using developing the app. That with this interface, so I will use entity framework to create this behind make the database.
Okay. Fine. There's another Prince.
Hello, Prof. So I will approach it from the backend part, I mean the database part. I'll start by identifying the entities. So as we explained earlier, entities are the things that you want to collect data on. So once I'm able to identify them, I will also go ahead and identify the relationships between the various entities that I have identified. With that, I should be able to modify and normalize the database and then start the coding from there.
Okay. All right. Thank you. Let me come back to Abdul Razak. Can you explain what you said earlier?
So what I meant is that I will use classes to develop a front end. Thereafter,
But do you start from the front end?
No, I'll do the model first. That's the classes.
Okay, yeah. You do the model first. Okay,
So
that's right.
the model first. Then I'll do the controllers. That one. So after that one, then I'll create a migration. So that I'll use the entity framework. That's C# side. So with that one, it will create the database for me.
Okay. But then if you are having this raw data, this is the raw data. How do you tackle this raw data first? What do you do with these items on the form?
Hello, sir.
Okay, all right. Go ahead.
Yes, I think as my colleagues have said, basically you have to first of all understand.
We can't hear you anymore. Is it Erasmus?
And others, and so
yes, sir.
Please,
Yeah,
we
Prof.
can hear you. Say it all over again.
Okay.
Hello, sir.
Go ahead.
I'm saying that based on basically what you have presented, you can have seen data. I have seen something that is gender. I've seen something on religion, and then those things. So basically, some of these things will be tables on their own with primary key, so that they would, like, a relationship will be created amongst them.
Okay, Sadiq. Who is?
Hello, Prof. With this, the first step is to identify the various relations, the various objects, and then group them by their relations. Then you have to go through the normalization process after that, after you've been able to identify the various relations.
Okay. Yes, I think that you all know what where to start from. But there is another, is that Erasmus who just spoke? Second.
Yes, Prof. Before any design of data, first of all, you have to know exactly what they are looking for by questioning those that will give you the contract to design the data for them. So by knowing that, it's from there that you will see if you have to start from the front or the back. So this is the way I think it can go. Thank you.
All right. So once you are able to identify what data should be stored, to you, it doesn't really matter. You can even start from the front because you've already identified what data could be stored. Is that not it?
Yes.
Okay. All right. But what happens to if you don't do the database and then know that much about what validations and then all that will be applied on various data, and then you start from the front? It won't create problems for you. All right. Now you've all made very good suggestions, meaning that you're working on the use of this. In actual fact, anybody who is given this can create tables out of this, develop front ends. I mean, those who have been taught this sort of thing before, to be able to create tables out of this, develop front ends out of this, and even be able to save data. And then some giving you other tools and so forth to pull these things to become attributes. So somebody can start from here and say, okay, then enumerator, supervisor, the supervisor signal, phone number, so and so. Maybe somebody will say enumerator, enumerator signature, phone number, date, together with supervisor signature, phone number, date will be in one relation. Then the person can create a table and put this thing into one relation. But the question now is, the way you did it, is it right? Is that the best way to do it? So as to gather these things and then create a script for them and we putting some data into them is not a deal. But whether your tables have been properly done, that will not create certain issues that we would be encountering or discussing in the future. In your view, if somebody looks on this, where we are now, enumerator, and create a place for enumerator signature, phone number, dates, and then put together, you put supervisor signature, phone number, date into one relation, is it proper or wrong?
He said it is wrong.
Why do you think it is wrong?
Now you mentioned that each cell should have only one attribute.
Okay. It is wrong, but that's not the reason why it is wrong. You see? So now, any other person who wants to attempt why you think it is not correct to be that way. Okay, Isaac.
Hello.
When you do that and you put all that information together, you are going to have redundant data very soon when you are
actually saving data into it. There will be a lot of redundant data. You are very right. Daniel, any contribution?
Yes, sir. So I see two entities here. We have the enumerator and the supervisor. Putting them in the same table. Okay, so you need to create two separate entities here because they are two different sets of data, and then link them via primary key and foreign key.
That's right. I think you've taken us one step ahead. So we would not have, in this case, the two of you have answered it correctly. We will not have only one relay or table here. It will be two. Okay, so then you begin to realize that the fact that anybody can get up and begin to create forms and then putting data into a database does not necessarily mean that the person has done it well. In fact, if you put all this, the two, supervisor and enumerator, all into the same form, and then not only on the same form, but into the same table, and then let's say we have 10 numerators, one supervisor. So we will say that we'll enter 10 records here. And when it comes to the supervisor, we will repeat the same supervisor for all the 10 of them. Then we come and 10, maybe another 10 enumerator, we will repeat 10 the same supervisor for 10 of them. So you see a lot of redundant data. So the fact that we can just say these things, and so we can create it right now, and then people just look at it and then begin to create tables around and then put in forms. It's even easy. There are a lot of tools that can even do the forms for you, and then you start saving data into it. Does not mean that you have developed an efficient system. Okay. So the first thing that you should do is to identify the entities. So when I take this, after careful analysis of this form, you can identify the entity. So you maybe mention the entities are just the same as, so to speak, the relation or the table. So now I can look at this one and then see carefully. Now, okay, this one can go into enumerator table, maybe supervisor table. Then I'll go down here and analyze all this carefully. Maybe this screen that you are seeing may be 2 or 3 or even 4 or 5 different tables. You see, then you identify them carefully. Then you begin to come out with all the needed entities. It is not like you do it once and you are correct. You can, as you analyze, you can see that no, this one needed to be broken down, or this one could be combined, this one could. So you analyze these things carefully to identify all the entities. So the first thing that you need to do is to identify the entity. Okay. So let's take note of the first step is to identify the entities. The second thing to do, the second issue that we will need to think about is identify the attributes of each of the entities that you have identified. So for instance, if I come here and then I identify the entity to be enumerator, then the attributes will be enumerator's name maybe, or enumerator's code or something, then maybe signature, phone number, something, and so forth. Then I identify this entity to be supervisor, maybe supervisor's ID, supervisor's name, first name, second name, or something, signature, phone number, and other related entities. So that is the second thing. Identify the entities, identify the attributes for each of the entities. For instance, you know, this is a manual system that they gave you. If you look at this very carefully, they just say enumerator. They are thinking about writing the name of the enumerator, which is not bad manually, but then you as a designer would identify something more than just the enumerator. What do you think you as a designer you need to add to this relation enumerator? Anybody's view? Why you didn't get the question right, or yes, Isaac?
Could it be the enumerator first name and surname and other names?
Yes, you could do that one as well. You need to break the name down, as we told you that each value in a cell should be atomic. So that's correct. But apart from that, what else will you add to that entity as a designer of a database? Okay.
Sir,
I believe
is it
you add. What will you add?
I said primary keys there.
You must add a key. You must add a key. Okay. So you as this must add a key. So the next thing that I want to talk about, first I said you must identify the entity, identify the attributes, knowing at the back of your end, the one principle is saying that each value in the cell should be atomic or single value, not multi-valued. So you may be breaking down a numerator into first name, middle name, last name. The next point that I'll give you, number 3, is that for each of the relations that you have identified with their attributes, look through all the attributes over there and check whether any of them can act as a key to the records in that relation. So here we have enumerator's first name, second name, last name, signature, phone number, maybe date that he has been recruited or whatever. Which of these items or attributes can act as a key? Anybody? Yes, Prince.
Hello, Prof. So from what we have here, I think the most appropriate would be the phone number.
Okay, there will be the phone number. That's right. That might be unique. Okay. Any other person's view?
Prof, please, I think we can create an ID for the enumerator.
Okay. All right. The best way is to, but the question I asked, which of these could act as a key? So you will see that phone number can be a candidate, can be a key anyway, but the best solution is to create impose a key or a primary key on this table. Impose a primary key on this table by starting maybe by saying enumerator's ID. Though phone number can act as a key, we can look at it as a candidate key that we have not chosen to be our key in this instance from best practice. Okay, so we will have enumerator's ID, enumerator's first name, middle name, last name, signature, phone number, maybe date of employment or something. Okay, so that's what we will do over here. So when you see, we mentioned three things now. Identify the entity, identify the attributes, make sure they are not multi-value, the attributes. The ones that we multi-value, break them down. The third one is to identify the primary key. If there is no primary key, impose one on the relation. So here we impose one, we call it enumerator's ID. Okay. Now let's continue. The next thing of interest, you will recall last week we said that I even stress it over and over again that when we're dealing with relational databases, your eye should be on the record. So we call them record-based models. This record, your eye should be on the record. What data are we coming to save into this? And that will help you to be able to do a proper modeling. So it's record-based. So now, the next thing after identifying the primary keys is to go to the next one and do a similar thing. So when we come here, the supervisor's relation will do a similar thing. Maybe supervisor's ID, first name, middle name, sign name, signature, and all that. You move on down. You see that the table, this table is quite complicated. And you need to be very careful to identify the various entities. So when you come here, you see region name, district type, locality name, subject district, sub-district, and so forth and so forth. I want to get somebody's view from here. Which table or relation can you suggest that you get from here as you look at it casually? I'll be giving it to you as an assignment, a project. But as you look casually, because you need time to study it carefully, but casually, which one do you think? Which other entity do you think can be derived from here? Assuming every data on this screen is important to them. Nobody has.
Please, I'm thinking the entity could be maybe like the name of the place, and then the region, district, locality, and sub-districts can be the attributes.
Okay, so you are thinking that the entity name should be what in your view before the attributes?
Maybe something like jurisdiction or locality.
Okay, all right then. Well, I'll come back to you. Let another person also who has a different view. Isaac.
Prof, probably you will want to store all information about districts separately from all information about regions, and maybe all information about locality, if that's possible. So we might have three tables, three relations to store: region, district, and locality.
Okay. I will give chance for another person who may want to respond. Prince.
Prof, I actually agree with Isaac. I was going to say the same thing he said.
Okay. Joshua.
Yeah, Prof. I think we can have two of them, one for region and then one for district, and have a foreign key on the region, a foreign key from the district on the region pointing to the district, and that should suffice.
Okay. So the first suggestion will create problem for us, that we should put all of them, the region name, district, and then this into one district type into one table. What we need to do is what the second to the last student said, that even from here alone, you should have region table where you may have region ID, maybe region name. You can have district table, district ID.
5 silent signs. Your kidneys are failing.
What am I hearing? Is somebody telling us that somebody's kidney is failing? No, I'm the only person who has heard it.
Prof,
we had it.
Prof, let's go ahead.
When you are teaching, you shouldn't be bringing in things that are scary. No, if somebody's kidney is failing, if somebody's kidney is failing, is not this. Or he wants us to close.
It's a serious issue.
He wants us to close the class, eh?
Not really.
These things are strange and then fearful thing. May God forbid nobody's kidney will fail.
Amen.
Amen.
It will not happen. Amen. It will not happen.
Amen.
Okay. All right.
Amen. Amen.
Anyway, so I was talking about, you see, at the first glance, if you are not careful, you may think that, oh, this thing I can put all of them into one table, but no. So you may just have region table on its own, which may have maybe region ID, region name. You could have district table, district ID, district name. And even normally we look at the hierarchy. You see that these things in the form of hierarchy. You have region, district, sub-district, locality, and then so forth and so forth. So it will be a good idea that you look at, what do we call it? The various entities. So these ones, they should be different entities. Region ID, region name, district ID, this, and so forth. I'll come and tell you something pretty soon. One student did mention something about it earlier. So this work that I'm coming to give to you to do, take your time and then look through carefully and see which tables you can derive from this, and then eventually your database will be optimal. And ensure that you don't have what do we call repetitions and then all this. Assuming that the first student who suggested that we should have region name and this and then all this in one table, look at what will happen to that table. Let's say we have a region. We have a particular region known as, or let's even start from a district. Let's say we have a particular district, and in a particular, how do I call it? In the particular, several districts fall under a region, one region. So you may have several districts listed over here, maybe 10 districts. And when you come to enter the record for region, you repeat the same region name for 10 times in that table. So in any case, you've already introduced redundancy. It will still happen with even locality. So you can't put all of them together. It should be split into various tables. I don't know whether that explains to all others why we will need to split them. Okay. Joshua, your hand is still up. Do you intend to make a contribution or ask a question?
Sorry, Prof. I think it's the old hand. Yeah.
Okay. All right then. So I've mentioned so far how many things? I think identify the entity, identify the attributes, identify the primary key, or impose a primary key on the table if no primary key is seen, or obviously being a good primary key. Having known that, the next point I'm coming to give you, the next point I'm going to give you is now identify the relationship among the entities. For instance, you see this material we are coming to use. Maybe at the end of the day, you'll be getting maybe 10 or even more tables. And tables or relations do not exist in isolation. Among the records, there will be some relationships. As I told you, I think about the records when we are doing this. There could be some relationships. So after you have come out with quite a number of tables from here, you are now coming to draw what we call entity relationship diagram, which is actually the model on which relational databases are generally based. So you are now coming to see your enumerator entity, then you will see your supervisor entity, you will see your region entity, you will see your district entity, then you will see so many other entities. Then now you need to establish relationships among them. So maybe you take the first two here, enumerator and supervisor. In the relational databases, generally there are three main relationships that can exist among the entities. So if we take any two entities, we will be able to find one of the three relationships that we are going to talk about. We've been saying that everybody knows it: one-to-one, one-to-many, many-to-many relationships. So if you are able to take two entities and then you would look at them carefully, and then you can judge whether the relationship between the entities are many-to-many, then you will say so. There's a diagram that we draw. You draw the diagram, then you show that it's one-to-many. If it's one-to-one, you show that it's one-to-one. If it's many-to-many, you show that it's many-to-many. So that is the next thing you need to do: identify the relationships among the entities. But that also demands some understanding to be able to judge the relationship. For instance, if I'm developing a database for maybe some religious organizations, and they insist from business rule That for marriage, no, it's 1-to-1, one man, one wife, one man. Then if I actually have two entities, then in that case it is 1-to-1. But if I'm developing, let's say, for another religious sect, and they insist that I know for our Muslim brothers, it's allowed that you can marry up to 4, if I'm not mistaken. The some are here, so if I'm mistaken, they can correct me. You can marry up to 4. Then, when we are developing a database for such institution to keep records of maybe members, then your database or tables is going to read 1-to-many. I mean, one man, many women are allowed. Okay. Similarly, if I'm developing a database for some countries in East Africa, or even some villages in India that I was told, probably I might have been deceived, but as I was told, that it's even allowed that one man, many wives, one wife, many husbands is allowed, and it's a normal practice. If I'm developing database for that community, then in that case, I'll be confronted with many to many, which in fact, relational databases cannot address many to many properly. And that would also bring us to what we call normalization. We will do something about it and then be able to still make them 1-to-many, so that you don't implement many to many, which many databases, relational databases, do not even handle. So these are the ways that we explain 1-to-1, 1-to-many, and many to many. Then I will throw a question, simple question, and after that, we'll come and relate what we have said to some of the tables we have here. Now, let me find out from you. A doctor and a patient relationship, what is it? 1-to-1, 1-to-many, many to many.
1-to-many.
1-to-1.
Many.
Let's take it one by one so that I can see clarification.
Prof,
so that I see
please.
number one. Well,
Prof,
let me
please,
just call you. When I call you, then you talk. The first one is Prince.
Hello, Prof. So the relationship between the doctor and the patient is 1-to-many, in a sense that one doctor can take care of multiple patients.
Okay, so we'll end it there. The next person is Erasmus.
No, Prof. It's the same view that I have, so you can go ahead.
Okay, Wanda.
I believe many to many.
Okay.
In a situation where,
don't explain. Don't explain anything. Don't explain. Now, George.
So I think it's 1-to-1 because you need to maintain confidentiality of patients' information, privacy, and things. And then treatment is individualized. 10 milligrams of a drug might work for patient A, but patient B might need just 8 milligrams, depending on biological factors.
Okay, John Bright.
Okay, thank you, Prof. For me, I also think it's 1-to-1 because of related to what the one who just told what he said. Apart from that, the way you asked the question, you said a doctor and a patient, meaning one person, one person.
Okay.
So it's 1-to-1.
Okay. I think the discussion is quite interesting. But then the Maxwell.
Yes, sir.
We hear from Maxwell, and then.
So please, I also am of the view of many to many.
Okay, just end it there. Abdul Razak.
let's say it's one to many. One doctor.
One many patients. Okay.
And 2 or 3 patients.
Okay. Okay. I have been a lot of responses. So for those who haven't called, since we need to move on, we will move on. I would give you a chance the other time, the next time to also speak. The fact is, it is many to many. It is many to many. So one of you who mentioned many to many can explain to us why you think it's many to many.
I'm very happy. Okay, so for me, I have had a situation where maybe you go to a hospital, let's say, let me start with many doctors, one patient. Sometimes you can be referred to another department for a doctor to take care of you. So assuming there are 2 doctors, they can take care of many patients at the same time.
Okay. Yeah, very right. So one patient may be attended to by many doctors, and vice versa. How do I say it? One patient, many doctors, which is a scenario we all know. There can also be one doctor attending to many patients. One doctor can attend to many patients as well as one patient being attended to by many doctors. So it ends up being many to many. Recently, I just wanted to do some general checkup. They told us when we are growing, we should be doing this kind of general checkup to know our health condition. So when I went, I met a doctor who attended to me one-on-one. But that was not the only person I attended to. As I was even leaving, there were other people in the queue going to that one doctor. So that one doctor attended to many patients. Then I needed to do some scanning. They asked me to do some scanning to check some other things. When I went, 3 doctors were standing there. They asked me to lie down, and they do all sorts of things. 3 of them, they were doing the test, and they were talking among themselves. So do you think this one, the way, is it normal? Then I say, yes, it's normal. This thing, the 3 of them. So one patient, but then 3 doctors attended to me at the hospital. So in that case, it is many to many. The many to many relationship, unfortunately, is not represented in relational databases. So in that case, you will need to break the table, the 2 tables. You will need to create another table out of the two, which I will be talking about later on, so that they will become many, one to many, so that you don't have many to many to represent. Okay, having said this, maybe somebody has some rebuttals on the many to many issue before we continue. So if you have rebuttals, you can speak now. Okay, it means
Hello,
everybody understood. Okay, you can speak.
It's not a problem. You can just make a junction table between them to make many, so that you have many to one and then one to many. So a junction table just between them.
I can't hear you well. I couldn't get there.
I said you just create a junction table between the many to many tables. That's all. To normalize it. A junction between the two, the many to many.
Okay. So you move. What you are doing is to go ahead and tell us what we should do when there is many to many relationship.
Exactly.
That's right. That's right.
Exactly.
Okay. Daniel.
Hello.
Prof.
Yes.
I'm just confused. Do we have many to many? I know that we have many to any, but not many to many.
You have many to what?
Any, but not many to many.
Oh, we have many to many.
But it's many to any, not many to many.
We have many to many.
Okay.
Maybe you can cross check. We have many to many.
Oh, okay. We will talk
There are
about
still.
it.
Yes, we will talk about it as we move along. But
when we read
you can also do your research and you will see.
I
There
thought
are
it's
certain
many to
there are still
any.
some.
Okay, because of the any, you can say okay, any is many. Okay.
Yeah, any is actually many, is that not it? Okay, there are still a lot of hands. Do you all, if you don't intend to raise your hand, you can lower it now so that I will know those who have raised hands. Okay, Maxwell.
Prof.
Mm-hmm. Okay. Then Wilberforce, your hand is still up. Do you want to say something? Otherwise, you lower it. Okay, I think we can continue from there.
Prof.
Yes.
So when we are recommending the many to many, the use of the primary keys wouldn't it in a way duplicate the table?
That's the issue we are having. So anytime we have many to many, there is, you see, one of the students was trying to suggest what we should do, which I first even said that we'll wait, and when we get there, I'll explain that one. You create another table out of the two. The two tables that you are having that are creating the many to many for you. You create another table out of the two. Then you will move the primary keys of each of the tables into the third table to become foreign keys. Because I haven't talked about foreign keys, I don't want to explain that one at the moment. So you can implement the many to many unless you break it down and then move the primary keys in both two tables into the new one. Then they will become foreign keys there. In that case, you will see that you becoming one too many. Then the other side one too many. Then it will take care of the problem.
Thank you.
Yeah. Thank you. Okay, so let us now continue a bit, and I will allow you to ask more questions as we move on. Now, I mentioned a couple of things. Identify the entity, identify the attributes, identify primary keys. If none is present, impose one. Make sure that as you identify the attributes, you remember that you don't have multi-valued items in your relation. Then we say, I now identify the relationships. There is one way identifying a relationship becomes quite easier. So the next thing I'll talk about is the entities as you see them. They exist in hierarchies. The entities exist in hierarchies. So you can look at the entity and then you ask whether this entity or this table is the parent table or is a child table, or that is a grandparent or grandparent or whatever. So once you are able to determine which one is the parent will normally be at the higher hierarchy than the child or the grandchild. For instance, if we have, let's say, from this data that we are having here to explain that fact, if I have region table and I have district table, which one do you think is at the higher hierarchy? Anybody at all?
Region.
Okay.
The region.
Region. Okay. So you will see that region is at the higher hierarchy. Okay. So the moment I see region to be at a higher hierarchy than district. Okay, now after district, let's say I identify, let's say for whatever reason, we want to also break down to move down to sub-region. You see, sub-region is also at the lower hierarchy than district table. So let's say we have district table, and we have sub-district table, and then we have maybe locality table. So when you look at these things very well, then region could act as the parent to district. District may act as a parent to sub-district. Sub-district may be a parent to locality or something of that nature. So once you are able to see the hierarchy, then it makes life quite easier for you immediately. Because one, the parent here is region. The immediate child is district. So immediately from the parent side, you can establish that from the parent side to the child side will be 1 to many. 1 to many. Immediately you can establish that fact because one parent, many children, which is normally the case. It's normally the case. One parent may have many children. Okay. But then, if you observe very carefully too, you will see that even though region has a grandparent sub-district, we will not make the link between region directly to the sub-district, but we will do it from here because district has immediate child, which is sub-district. Then from district to sub-district, we will still have 1 to many over there. Then from sub-district to locality, assuming that these were all tables we identified, then sub-district to localities will also be 1 to many, and then so forth. So you see that we are now joining the tables, trying to identify 1 to many. And then we talk a lot about many to many already. And we said there is a way we can manage that one as well. But then if you come to many to 1 to many relationship, if you are able to identify the parent table, then the child, the immediate child table, and so forth, that will help you to be able to establish 1 to many, 1 to many, 1 to many among them as easily as possible. Okay, I can pause here to take 1 or 2 questions before we continue. Wilberforce. Wilberforce, your hand is up.
Sorry.
Maybe you don't mean it. Okay. Okay. So, having said that, if anybody has any question on this, otherwise I'll be saying something else. I'll add something to what I just said.
Hello, Prof. I have a question.
Okay.
So I might drive us back a little. I want to find out what to look out for when choosing a primary key. Like, is there something
Okay.
to look at?
When you are choosing the primary key, look out for the attributes whose values will be distinct. For instance, if you want to choose a primary key for, let me give an example from what we are doing. Let's say I want a primary key for supervisor name. Then I say maybe supervisor name will be good primary key. Then I would think that no, what happens if 2 people have the same name? Then the moment I think like that, I say no, it can't be possible because the supervisor name cannot be a primary key because 2 persons can have the same name. So you begin to look out for the attribute that will give you unique values. You remember even somebody mentioned phone number earlier because the person was thinking that phone numbers They will be unique. Phone numbers for each person will be unique, but not sometimes all the time. So we don't want to use it. What if two people are sharing the same phone? So we don't use it because we doubt that, okay, maybe there can be a situation two people share the same phone. So look out for the attributes whose values will be unique throughout. If you can find one, then you impose one on that table and call it supervisor ID. Then you yourself will generate numbers or values that will be distinct. That no two values will be the same. So that's what you look out for. Is that gifty?
Yes, yes, sir.
Did,
Thank you.
did, did you understand this? Did you understand the explanation?
Yes, I do.
Okay, that's right.
Thank you.
Okay. Michael.
Yes, thank you, Prof. I want to ask that with the table we are working with, the document, you said entities. Now, is there a criteria you use to select the entities? Because I have a challenge selecting the entities from the document you are sharing. You can help me with that. Maybe if there is a criteria.
I don't understand the question. Can you come again?
Yeah, I'm asking that the document you are sharing,
Mm-hmm.
you said the first thing is to identify the entities in the document before you start with your database line.
Yes.
And I'm asking that is there a criteria for looking that you use as a guide to look for the entities? Because I'm struggling picking the entities from the document.
Yeah. I know it's going to be a lot of struggle for most of you, at least those who have not done these things before, even some who have done it as a course, but not practically trying to model and then write a program and all those. Because that's all the reason why I brought it. I don't want to take it for granted that we know. So you yourself, because an entity is made up of related attributes. So as you look through the content of this, which normally what you'll be given at the workplace, if they will ask you to develop a system for them, they will only give it to you and they will be thinking that's the same thing that you are going to represent on a database. But no, you as a technical person will now begin to apply these concepts that we are learning. So your question is, how do I know that this one, how do I come out from them and know that this one will be an entity and this one will be that? Entities are made up of related attributes, you see, and then also bear in mind the redundancy we're talking about. So maybe you can work in your group as I'm going to give this into a group. The group should do its own research, brainstorm. In fact, if this thing is given to anybody, it's not something that you can just look on and then say, I know how to do it, and then just in a matter of minutes you are done. No. You take your time and then begin to see carefully which related items here, which items over here are related and can fit into one table. Sometimes you do it, then you say, this one I think it should fit here. Then this one need to split it. So it's a matter of modeling. And it's not like a one-time thing. You need to study it carefully as you go along. You say, okay, this one will fit into this one, or this one is too large. There will be repetition. I need to break it down, and so forth. So as it is now, I do not expect that as you are looking at it, you are going to just mention by heart all the tables and these things that will be here. So that's why I'm giving it to you as a project. So you can brainstorm in your group as you apply principles of which records are related and you put them into one table. If you see another table which records are related, which fields are related, and you put them there, sometimes you see that the repetition will come. Then you can break it into two so that it doesn't repeat, we don't repeat data and so forth and so forth. So it's a bit of analysis that you need to actually do.
Yes, thank you.
Michael, you have spoken already.
Yes, sir, thank you.
Okay, you can lower your hand so that we know. Okay, I'm going to make another observation here that will help you. When you observe this data that we are using to explain the theoretical concept, I decided to bring it here so that we don't just define those terms without practically understanding what they mean. Now, when you come here, and then we have a numerator and supervisor. I just talk about the one that will be parent and the one that will be child. From these two tables, which one do you think will be the parent? There can be parents and a child, or there can be two children that are of the same level. So if they are of the same level, you can also tell me. Now, a numerator and a supervisor, which one will be the child and which one will be the parent?
The supervisor as parent, the numerator as child.
This Fortune, is it Fortune that has spoken? Fortune has never spoken. She has.
I did. I said it's the supervisor that will be the parent and then the numerator being the child.
Yes, that's very good. That's very good. So now, if that is the case, what kind of relationship that will exist between the numerator and then the supervisor? Anybody? One to one, one to many, many to many.
One to one.
One to many.
One to many.
Yeah.
Yes.
One to one.
A supervisor can supervise multiple enumerators.
Okay. So invariably, it will be one to many. Invariably, one to many. And therefore, one supervisor may have many enumerators. So when you draw the entity relationship, you should show one to many. Now, but just saying so is not enough. It's just a matter of saying one to many. But what actually makes it one to many? What makes the tables one to many is that you see the primary key of the supervisor, who is the parent. You take that primary key and you can go and impose it on the numerator table. So it will be one of the fields or columns in the numerator table. Once you do that one, then you say that the primary key here has another column here in the numerator table, which is the foreign key over there. That is actually what makes them one to many. So anytime you observe one to many relationship, what actually makes it, not theoretically or implementation wise, what makes it one to many is that you take the column here, which is the primary key, and you go and impose it on the numerator table as one of the columns over there. Then implementation wise, there is a way we link it when we are creating the tables. Then logically, the system knows that there is one to many relationship between the two. I hope that goes down. If that doesn't go down, you can breathe in and breathe out and then make sure that goes down with you, because this is something that you are going to do practically. I don't intend to teach these things theoretically and we go without knowing anything when this course is over. When this course is over, you should be able to design the database and then work with the database. I told you we are dealing with practicals and then also some practical aspect and some theoretical aspect, because theories are very important as practicals are also important. This and basically MSc and MPhil. Most of the MSc students want they will also continue with the theoretical concepts. So we are dealing with the two. Okay. So if you don't understand that concept, make sure you grab it once and for all. So far as there is one to many, the portion that has one, copy its primary key and go and impose it on the one that has many. So supervisor's ID primary key will be imposed on the numerator's relation or table, where it will become foreign key over there. So that links the two relations. Of course, you know, if you are a parent and you give birth to children, we normally do that. So these things are all taken from what we do. You impose your sign name, so to speak, to link you and your child. You have to impose your sign name on the child. You see, the child, your sign name, you can take it as your primary key. So you, the parents, if we don't do so to impose our sign names on our children will be lost. So you impose it. So the parent must impose his primary key on the child, and on the child is a foreign key. So that is the kind of things that we do. Any questions so far before we continue?
Please, if I got you right, you said that if something is related to a few others, like in a situation where it's one to many, the primary key of the one is a foreign key on the many, like the individuals of those many.
Exactly so.
And if it's many to many, does it go the other way as well? So that, let's say for a doctor in a particular case,
if this many to many,
Mhm.
if this many to many can only be implemented. So you create another table. You create one table. You add one table to it. That table that you are adding, the patient table will be there. The doctor table will be there, and you create another one and you name it. Then you copy the primary keys of the two of them and come and put it inside the new one.
Oh, okay.
You see the practical way of solving a problem. That's many to many, but I'll be talking about it again as we go along when we reach normalization. But if it is one to many, copy the primary key in the one side and come and dump it into the many side.
All right, thank you very much.
Okay, all right, George.
Yes, sir. Sir, please. So the many to many, can we apply to the supervisor and numerator case over here too, if we are able to make two tables and make the case out of it, and when superimpose the supervisor across both
The relationship between the two is already one to many, so we can say it's many to many. So we can change it to many, since it is not. It is when it becomes many to many that we will do that. But if it is already one to many, we will not assume that it's many to many.
Okay, sir. So
okay.
Thank you.
Okay. Opoku. Okay, Abdul Zakaria.
Yeah, Prof. Prof.
Yes.
Okay, good evening. This question is not related to actually what we are doing now, but we are a group who have been looking for you since last week with respect to the project supervision.
But it's not related. Let's finish the class before you ask this question. Since we are still in class, I think when we are ending, I will open the floor for any other discussion.
Okay, sir. All right, then. Thank you.
All right. All right. John Bright.
Okay, Prof, please, you said something I am trying to recall. You said when you move, when we have one to many, and then you move the primary key from the one side and dump it at the many side, is it secondary key or foreign key? That's what I was trying to recall. Why?
It's foreign key.
Foreign key.
We call it foreign key over there. But then let me just clarify this. We don't move it to, we copy. So the primary
Copy.
key will still exist. The primary key will still exist in the supervisor's table, all right. But you will create a new column with the same name, the same data type, and so forth, and then you put that one into the child table. So we don't move it as if it doesn't exist at the source. It will still be there, but then a copy will be at the child side where it will be acting as a foreign key.
Okay, thank you so much, Prof.
Okay. Any other hand up? So that we should be running off.
Debbie's hand is up.
But it's
Prof,
not
my hand
speaking,
is
so
up.
maybe it's not ready. Debbie, I mentioned
Prof.
Debbie, it doesn't respond. So we'll move to the next person.
Hello,
Who is
sir.
the next person?
Yes,
Sir.
please,
Abdul, you just spoke, so you should put your hands down. Is that not it?
No, I didn't speak. Oh, it wasn't me.
You haven't spoken.
Yes.
Then go ahead. Then go ahead.
So I was just wondering, instead of me creating two tables, and then linking them with the primary key and the foreign key when it comes to the enumerator and the supervisor, then can't we have one table for it, and then with the help of views, we can be able to filter the data we need for each side of them. So that's my question.
If you have only one table, you have a lot of duplicate data in it. The supervisor side of that big one table will be duplicated. In relational databases, we want to limit duplication because the same supervisor may be supervising so many enumerators. For instance, if the supervisor is supposed to supervise 1,000 enumerators, then the supervisor's name at that column will be repeated 1,000 times. You see the problem? It wastes memory, wastes space, wastes everything. Even when it comes to issues, we'll be talking about update anomalies and all sorts of things that it creates. That's the reason why we want to separate it. If we separate it into different tables, we will not have that large duplication. The duplication will only simply be the column that we copied from here and we send to the child table as a foreign key. That will be the only duplication.
Thank you, Prof.
Okay. When we come to normalization, I will be demonstrating something to you. And then you will see the quantum of duplications that we can eliminate by doing normalization. The next question is Isaac. The next question is
Yeah,
coming
Prof,
from Isaac.
on that front, what if we do maybe staff table where we have all the staff with their IDs? Then we can get a supervising table and an enumeration table where we can just use their primary key to link them up.
Because of the fact that I do not want to be talking about too many tables at the same time, I limit the discussion to supervisor from the data that we are looking at, supervisor and enumerator, without any like staff. But we are saying that we should have staff table. What would the staff table do here? If this is the form you have been given from statistical service to develop a system for them. So you are looking on this. So when you create a staff table, what is it coming? That means some of the records will represent a supervisor, some will represent a numerator, or how will you going to do that?
Okay.
So the next, it's even already time. The next thing I wanted to talk about, maybe we can do that one next week. We'll do that one and we'll clear the normalization at the same time. Because the discussion that I had so far with you could take care of all the other things down here. I think all this, I can just mention them briefly next week. Because what I'm talking about now is more detailed than what is in this chapter over here. Okay. So when we meet next week, we will conclude the discussion on the relationship. Then I'll tell you the next thing after the relationship. I'll tell you the next point. Then the next point, I think we have our 2 or 3, 4 points again to mention. After going through all that, I'm sure you can be able to perhaps be able to do a modeling. So I'll be putting some questions around this form. Make sure that your classes are divided into about 4 or 5 students in a group. And then this will be handed down to you for modeling. You will do the model first. After the model, I'll ask you to bring some front-end interface and then use some advanced concepts, including store procedures and triggers, functions, data replication techniques to do certain things on this same form. Then I'll be sure that you understand those concepts and you can apply them. Okay. On this note, if you have further questions, somebody raise a general question, you can raise the general question again. Yeah, whose hand is first? Abdul Zakaria.
So, Prof, I just wanted to find out with regards to your group, we have the evening class and then the weekend class. Are we forming the groups by coming together all the other cohorts, or
No, form the groups based on your cohort. Form it based on your cohort.
Okay, thank you.
Okay.
Prof, please. Currently, the weekend, the C and B cohorts are together. Currently, what about that one? We have class together now. So does that mean it should be together?
When do you have class together?
Sorry, on weekend. Currently, because B and C are together on weekend because of the strike, they put us together. We've been having one class.
So you don't meet how do we call, you don't meet Dr. Dansu anymore, is that the case?
They meet him. He's the only one on Sunday now, but the rest all we join on Saturday.
Then I'm telling you that for my course, arrange yourself based on the cohort, because it's different. The different lecturer.
Okay.
For my course.
Thank you. Thank you.
Any other concern?
Yeah, yes, Prof.
Okay. Go ahead.
Hello, Prof. Hello.
We are hearing. Just go ahead.
So it's about Sakai courses on the Sakai. A lecturer has given us assignment. That's algorithm, data structures, and an algorithm. And then he wanted us to submit it on Sakai. He wanted us to also do quiz on Sakai. But some of us, our courses hasn't appeared yet on Sakai yet. I registered long ago. So he asked me to contact the GA. I contacted the GA and he said, because I'm MPhil student, I have to contact Dr. Solomon. I contacted Dr. Solomon too, but he's not responding to my messages. And the assignment, we have to submit it online. So in case if I couldn't submit it, so that's my concern.
It will be best to address this to the lecturer. And then Dr. Solo is supposed to help you. Maybe you can still try to get in touch, but you can explain this to the lecturer. Most of the time, Sometimes some students do not get on Sakai on time. So if you give assignments, then they may be missing that assignment. It creates problems for the lecturer and the student as well. Because when the lecturer is marking, your scores will not be there and it creates problems. So normally for me, beginning like this, though even if I put something on Sakai, I still give them to the students to work on. Otherwise, some students will be left out. So speak with the lecturer and then Solo, they are the two key people I think can resolve this. If it were my course, I will know how to go about it.
Okay, thank you.
Okay. The next
Yeah.
person will be first. Or Debbie.
Yes, please. Yeah, please, I joined a little late. I didn't have light, so I wanted to know what the assignment was on. I heard something about creating databases, but I didn't get the whole thing. I don't know if you can quickly go through.
It is assignment to be postal data, so you will see all the requirements. But then the material I'm using to demonstrate is the assignment to be based on that material. But you are going to do it as group work. So
Okay,
it will be
sir.
posted later.
Okay, thank you very much, sir.
Okay, all right. Could you?
Doc. Hello, Rob.
Yes.
Yes. Like I said, some of us are humbly requesting you become our supervisors. So there was a form that was sent across, and we've completed it. Dr. Solomon placed the form on the page, so we filled it out and then submitted. But we want to know whether there's a schedule for us to meet you or anything like that regarding the submission.
That's the initial stage. Sometimes what happens is after you select the supervisor, there are situations where maybe 30% of the students select one person, and then 1% of the students select another lecturer. Then those things are not acceptable because we are all supposed to have almost equal number of students to supervise. So, though you may choose me to be the supervisor, it may not necessarily end up that way. That's what I can say at the moment. So if it happens that so many students select me more than the quota that the department would assign to me, then some students would be reshuffled and possibly be given to another lecturer who may have less number of students. But this is the way I go about my supervision. Once the supervision list is out and I've been given, let's say, 10 students to supervise or 15, I normally, because of the fact that most of you are weekend students and some are working and all that, what we do is I have days for student supervision, normally Monday evenings. But then we can agree. We create a platform for ourselves. Then all the 10 or 15 students will be on the platform with me. Then we start the communication. I would have a time with you like I'm having now, take you through what you should do, then how you should do, you answer all your questions. I'll look at your proposal one by one, pointing this out to you, that, and so forth. Then we take it out from there. Then I'll ask you to submit something on a particular date, showing you where, guiding you and showing you what you should do here and there, and then so forth and so forth. So we will be meeting online. Occasionally, we will meet face to face. But because of student numbers, it is very difficult to be addressing, spending so much time face to face on individual students. We won't even get the time. But then it works. Once we come online like this, you can ask all your questions. I'll give you all the explanations with even some materials, and then be guiding you, submit your assignment. I'll look at it, highlight places. It comes to a time that you submit your work, and I will say Monday, Tuesday, I'm going to meet all my students. Then we will start from Monday. That one by one. Then we look through, I'll guide you this, that, and so forth. And so that's how I handle my supervision, and it works so effectively. But for every individual coming to my office one by one, I can't even manage it because it's even not necessary, because we can still meet the one by one over here. I can ask you to share your screen and demonstrate to me what you have done. And I will be able to be pointing out this and that to you. It's just the same as you come to my office. So that's what I handle my students. So let us hope that at the end of the day, I do not get more than necessary, or I do not exceed my quota, and some of you will be given to some other lecturers who probably do not get the needed quota. So that's what I can tell you at the moment. Once the deadline has ended for the submission, the coordinator will be compiling all the lists and share with us. And once I'm giving the number of students that I should supervise, or students who this, and then after the reshuffle and whatever, I would speak with one of the students who will become like our, what do we call it, prefect, what do we call it, class rep, who will create a WhatsApp group, and then the thing starts from there. So that's how it will go. I hope you have understood the explanation I've given.
Yes, sir. Thank you.
Okay, we may have to be ending it here today. There is only one hand I will attend to. I think only one left, Emmanuel also.
Yes, Prof. Please, my concern was the other time you said you were going to let us have the textbook.
I didn't give it to you.
No, please.
Okay. I thought I forwarded it.
I think you gave it out.
Prof,
It's still the
please, you forwarded
that one.
Prof, please, you forwarded it to me, and I give it to them. I put there on the page. Maybe he didn't get.
Maybe he didn't open the page, so
Yeah,
you should
so
go
if
to
he
the page.
and anybody who requests anything in the page, we are all sharing like that. So you should request, they will give it to him, please.
Okay, that's right.
Prof,
That means I'm doing it. Yes.
Prof, please, how about your research group on cybersecurity?
And the
If you want to
research
join.
group. You didn't see the Google form that you were supposed to complete. Have you completed it?
Yes, I've completed it.
And that will also be compiled and be shared with you, those who belong to various groups. But for your information, next week, I told you that every last Tuesdays of a month, there is a research seminar. There is going to be a research seminar next week at 1:30 p.m. on Tuesday. Because of the fact that many students are new and struggle how to formulate research area, how to formulate research topic, and so on, I'm going to put a professor on it to come and teach us how to find a suitable computer science research topic. So that's what I'll be doing next week. That a professor will come and take us through how we can formulate appropriate research topic and then so forth. It's going to be online. It's normally 2 hours, from 1:30 to 3:30. So I will expect all of you, when the link is shared, to join to help you a lot. So that's what we'll do next week.
Prof.
Yes.
So suppose you see we're told that for MPhil students, they have to get two supervisors. So suppose you have, let's say, for cybersecurity side, you have you and then Dr. Ansong. So suppose Dr. Ansong, Dr. Ansong has taken you. Do you have to see you also for another for supervising?
Yes, for both of the supervisors, the supervisor should agree to supervise your work. Whether it is the main supervisor or the second supervisor, they both. But the first thing is the main supervisor that matters first. Then you work on the second supervisor.
Okay, so for us, Dr. Ansong has created a WhatsApp group that he said he will meet us.
So that means you will need to find the second supervisor.
Yes, and that's you.
Not necessarily. The second supervisor can be any other lecturer. It can be any other lecturer, not necessarily me.
No, I thought it should be in the area that you want to.
Not necessarily. Not necessarily. Once the main supervisor is a what do we call it, an expert in the field, that is enough. Once the first supervisor and an expert in the field, that is enough. The others can come from any other field.
Okay. Thank you.
Okay, on this note, we would end the class here today. We will continue next week. Thank you very much for coming. And I hope start thinking through how to do some of these things. On this note,
thank you, Prof.
Class prep, please, if you can get the book.
Which cohort are you, please?
What A?
A.
Yes, please.
But cohort A, your things are different. Cohort A, your things are different.
Yeah.
I don't know, but I think
it's not the weekdays.
Yes, we are weekend. B and C, we are weekend. So that one you have to call Joseph. But I think this man is giving her the same thing. So in that case, I can still share with you.
Okay.
So what I'll do is send me a hi, and then I'll forward anything I have under him for you.
Okay.
0247
0247
433 779 779
779. Okay. I'll do it right away.
All
Thank
right.
you very much.
Welcome.